So this is Sra468 Visual Analytics. This is our final exercise. We are group Ics2, but we are doing the IAM project. We are Joey Sweeney, Ryan Connolly, Seema Farzanaghan, and Dan Zapochny. So for task one, there are three main questions we have to answer. Create visualizations to understand the volumes and distribution of the computing facilities at the Bank of the World. For example, how many machines in different categories? Where are servers, workstations, and ATM machines located? And where are the large and small regions located? So for how many machines of different categories, to create visualizations to understand the volumes and distributions of facilities, we first had to find the type and quantity of the machines based on both machine class and machine function. To find this, we created a dashboard featuring a tree map and a chart. We use the tree maps to help visualize the class and function of machines as well as how the category sizes related to one another. The chart was created to easily see the actual count of the machines organized by the machine class as well as the number of machine classes and functions as they fit together. The tree map visualizations allow us to see that there are three categories of machines: servers, workstations, and ATMs, as well as different categories that each machine class fits into. Workstations are either tellers, loans, or offices, and servers are either web, email, file server, compute, or multiple. All ATMs are classified as ATMs for their function. The tree map also shows that the server class is the highest quantity, followed by workstations, and finally, ATMs. The chart helps us pair the actual amount of machines per category. The server class contains 566,109 machines, followed by the workstations at 203,369, ATMs at the smallest amount at 37,587. You can also see the majority of servers are either classified as compute or multiple for their function. Web and file servers are the next most common function for servers, with email being the least common function. For workstations, the majority are classified as being offices, with loan and teller being a little bit below half of the quantity for each. So for our next question, we're answering, where are the servers, workstations, and ATMs located? To answer this question, we created a map containing each Bank of Money machine location with ATM servers and workstations represented as dots with different colors. We then created another dashboard containing three maps filtered with each machine class. Using these visualizations, the answer to the question, where are the servers, workstations, and ATM machines located, becomes clear. All machine classes are very evenly distributed across Bankworld. The three filtered maps on the dashboard clearly show this by showing dots for each machine all over Bankworld. It also informs us that many Bank of Money locations contain multiple different types of machine classes. The last question we answered is, where are the large and small regions located? To answer this question, we analyzed maps based on business unit classifications. We noticed that there was a steep drop-off between the number of offices in headquarters and regions 1 through 10 compared to regions 11 through 50. For this reason, it made the most sense to group the former as large regions and the latter as small regions. Spatial maps work best to show this, seeing as the question is asking where. So, as one can see from analyzing these two maps, there are four clear headquarters locations in the northwest, east, and central regions of Bankworld, shown by the dark blue dots in the large regions. And then the maps also show that the regions with the large number of offices also span larger areas than the small regions. Overall, the large and small regions are fairly evenly spaced throughout Bankworld, except for the headquarters, which are strategically placed in the corners and center of Bankworld.
In task 2, we were tasked with creating visualizations of the health and policy status of the entire Bank of Money enterprise as of 2 p.m. on February the 2nd. To create the visualizations of the healthy and unhealthy parts of the network, we created a map on Tableau to lay out our data points on. We separated the policy status into 5 categories of ratings: healthy, moderate deviation, serious deviation, critical deviation, and possible virus infection. For this analysis, we consider healthy computers to be machines with a healthy policy status. Unhealthy machines are those with the statuses of moderate deviation, serious deviation, critical deviation, and possible virus infection. By creating this visualization, you can clearly see which machines are working properly and which are not. Along with this map, we created a bar graph and count chart to show the exact number of machines in each category. The count is shown in the policy status chart. This chart shows us that there are around 150,000 machines that are malfunctioning. To see where those machines are located, we created a dashboard with the map of all the machines and the bar graph of the health status. We then applied a filter and were able to see where the healthy and unhealthy machines were located on the map. The overall dashboard features the entire map to easily see where each status occurs. We then added a bar graph of the count of the machines at each policy status to compare them to each other. Both the map and the bar graph were color-coded for each policy status and labeled in a legend that was also added. To clarify exact numbers of the count of each policy status, we added a chart to the dashboard. Finally, we added a chart of the count of activity flags that are present in the machines. The dashboard helps us visualize several key points using the filtering option. First, the chart and bar graph allow us to see the majority of machines are healthy. However, there are 150,000 machines that are unhealthy. Of those unhealthy machines, most of them are moderately deviated. This warrants investigation into the deviation, however, it does not seem like an urgent concern. However, critical deviation, serious deviation, and possible virus infection should be top priorities for the enterprise. There is no location pattern on machines with healthy or unhealthy machines, as those machines are distributed across the entire map. We can also see that the activity flag does not correlate to a specific policy status. For instance, a normal activity flag does not indicate a healthy policy status because there are machines in critical deviation with normal activity flags. This pattern exists for all activity flags, and thus activity flags is a bad predictor of whether the machine is healthy or not.
So for task 3, our group had to design visualizations and interactions to allow the analysts to understand how the network changed over time. We also had to highlight 3 potential anomalies in the network and provide a visualization for those. For the first one, we were looking at policy status and the trends over the 2-day period. So we created this visualization right here to show how the different policy statuses changed from the beginning of February 2nd to the beginning of February 4th. You can see over time, the moderate deviations started off much higher than the other policy statuses and began to grow right away before slightly going downhill throughout the 48-hour period. For the serious, critical, and possible virus infections, they began to grow as time went on. We believe this is due to the fact that machines went from moderate deviation and got deteriorating more significantly, and that's why the other more serious policy statuses grew as time went on. You can see over time we also created maps at different various points throughout the 2-day period. Here's a map of the policy status at the beginning of the 2-day period, in the middle, and at the end, and we made a dashboard to see, to highlight the different policy statuses and see that it increases over time. Here is one where you see there's serious deviation, not at the beginning, but toward later periods. The critical deviation is the same trend, as well as possible virus infection. Throughout the time, not a single machine was recorded as being healthy in Region 10, which was the area that we did this study. We also looked at activity flag trends throughout the time period, and you can see we did the same type of thing as we did with policy status. Normal starts off much higher than any of the other activity flags and stays that way for most of the period. But as you go through this, you can see for these bottom 3 activity flag trends, there's big anomalies right here. As it's at approximately 11:45 p.m. on February 2nd, and we believe that this was definitely something to take note of. Over time, you could see that it grew back up to its peak, but that's definitely something to take note of when it went down to the lowest level, all simultaneously. So for this task, we identify our 3 anomalies. The first one being that there was no healthy machines in Region 10. As I mentioned earlier, you can see from the dashboard that they're all moderate deviations, serious deviations, critical deviations, or possible virus infections from the time period at the beginning at 8 a.m. on February 2nd to the end on February 4th. Our second potential anomaly is that they experienced their highest deviation levels during non-work hours. So when we look back at the policy status trends, you can see right here is the highest point for all 3 of these policy statuses, and they occur at 7 a.m. on February 4th, and they've been growing throughout the night when no one should be working on the computers. Our third anomaly we identified was that the activity flag trends, as we mentioned earlier, hit the bottom at midnight, which is also during times when there are non-work hours, and they hit simultaneously, which leads us to believe that there's some type of malicious activity going on. As we look at the dashboard we created comparing the policy status and activity flag trends at the same time, you can see that at the time they hit their lowest level, possible and virus infections are first identified on machines. And so we believe that there could be infections going across Region 10's machines. Finally, we created a visualization for the activity flags within Region 10, and you can see that the distribution of the machines and the activity flags they're experiencing, we found it odd that all the normal ones were located in the center, where the ones that were experiencing some type of issues were further away from the center. As of now, we believe that these 3 anomalies were fully identified through these visualizations, and moving forward, we'll make further investigations.